Good evening, ladies and gentlemen. Today we're going to be going through sum and product of the roots of a quadratic. We already discussed a quadratic equation, how to find the roots or solutions. And we discussed that the roots or the solutions are where the graph crosses the x-axis. Now we want to use the roots to find the equation. So we're basically going to be working backwards in most cases. Some cases on the Regents exam you may see it, on the test you might see it as well, where the question literally will ask you what are the sum and the product of the roots of the quadratic, where it's just a matter of writing it down based on the formulas. So starting with this, can we find a quadratic equation whose roots are 1/2 and 1/3? Well, what that means is that the answer, x equals 1/2 and x equals 1/3. If we work backwards from this, I can take these and multiply them. So I end up with 2x equals 1 and 3x equals 1. Okay, again, working backwards, getting it equal to 0. I have 2x minus 1 equals 0 and 3x minus 1 equals 0. Well, before we do that, we typically have them put together as multiplication. 2x minus 1 times 3x minus 1. Again, we're working backwards. So I want to get to my quadratic, so I want to FOIL this out. So I have 6x squared minus 2x minus 3x plus 1 equals 0. So my final answer, my quadratic equation, which is what we're looking for. Can we find a quadratic equation? And we can. My final quadratic equation is going to be 6x squared minus 5x plus 1 equals 0. So now I want to see if there's a connection between our coefficients, the numbers in front of each of our values, and the roots that we have in order to find the sum and product of our roots. So our sum of our two roots would be our root 1/2 plus 1/3. The product, we're going to take and multiply 1/2 times 1/3. Product being easier because the product of them is 1/6, because 1 times 1 you get your multiply across, and 2 times 3 is 6. For adding, we need common denominators, which our common denominator should be 6. So the first fraction I will have to multiply by 3 and the second one by 2. So I end up with 5/6 for my sum. So if I look again more specifically at the coefficients of our equation, our coefficients are 6, -5, and +1. And we can see in our answers, we have a 6, 5, and 1 in some way. The actual rule for this, the formula for this, is that the sum of the roots is -b/a, and the product of your roots takes your c value and divides it by a. So now we're going to use these formulas to figure out the rest of our problems. So number 1, find the sum and the product of the roots of your equation. So in order to do that, again, we want this to equal 0, like we would always. So we have 5x squared minus 7x plus 2 equals 0. So the sum of our roots is, again, -b/a. The product is c/a. So it's just a matter of plugging in our numbers. So negative b, so negative b is negative 7 over 5. So the sum of our roots is 7 over 5. The product, taking our c value, which is 2, over a, which is 5. So the product of our roots is 2/5, and the sum of our roots is 7/5. And again, from here, it's just filling in the formulas. Number 2 gets a little bit trickier. Number 2, they want us to find a quadratic equation in standard form when they give us the roots. So now we're going to take, again, sum and product of our roots to go and find our quadratic equation. So the sum of our roots, we're going to take negative 2 plus 3i and add negative 2 minus 3i. And if we go through and combine our like terms, negative 2 and negative 2 gives us a negative 4. 3 and a negative 3 cancels out, so those go away. So our answer for the sum is negative 4. The product, we're going to take and multiply our two roots together. And we get negative 2 times negative 2 is 4, plus 6i minus 6i, minus 9i times I is I squared. And going back a couple chapters, I squared is equal to our negative 1. Here, if we look at our I values, a negative 6 and a plus 6 cancel each other out. So I end up here with 4 plus 9, which is 13 for our product. So we need to take this and go back to the equation for sum and product. The problem, the sum of the roots, is negative b over a, and the product of the roots is c over a. Now, we can make any fraction, any number into a fraction by simply putting this over 1. So we can figure out a, b, and c based on what we're given here. So we have negative 4 is equal to negative b, so our b term is 4. Our a, which is in both pieces of this, our a term is 1 here and 1 here. They should always match up. If they don't, you did something wrong. And our c term is 13. So now if we know a, b, and c, we can put it back into our equation, because our standard form of a quadratic is just ax squared plus bx plus c equals 0. So a being 1, so x squared plus 4x plus 13 equals 0. And that right there is our equation in standard form. Okay, moving on to the next one. Okay, so for example number 3, it says to write a quadratic equation, and it gives us the sum is 3 and that the product of our roots is 4. So if I go back, remembering our formulas, the sum of the roots stands for negative b over a, and the product of our roots is c over a. So if the sum of the roots is 3, it's also the same as saying the sum is 3 over 1, and the product is 4, or 4 over 1. So from here, it's just matching up our letters. So I need to figure out a, b, and c. From here, we can see a is 1, And no, A will not always be 1 in every case. It just happens to work out for 2 of the problems. Your B term, and this is where you have to be very careful because it's a negative B. So if negative B is 3, what is B? B is going to be a negative 3. And then your C term, again, lining things up, C is 4. So our equation, again, ax squared, so 1x, plus bx, so negative 3x, plus our C term is 4, again, equals 0. And that right there is your quadratic. Example number 4, I'm actually going to go through in class. It's a little bit trickier, a little bit more complicated, especially because we have that k value in front there, and they're asking us to do a couple different things within this problem. So I hope you all have a wonderful evening, and I will see you tomorrow.